Hi, have a good day. I am K. Surya, working as Assistant Professor in the Department of ECE at SNS College of Technology. Today, in this video, let us see about a combinational circuit which is a multiplexer. A multiplexer is a digital switch which has multiple inputs and a single output. So you can say you're having 2 power n inputs and one output. So capital N represents the number of select lines. Here there are different types of multiplexers like 2 to 1, 4 to 1, 8 to 1 and 16 to 1. So based on the number of inputs, you will be deciding the number of select lines. For the case of 2 to 1, you can write 2 as 2 power 1. So capital N is equal to 1. So you will be having only one select line here. In the case of say 8 to 1, 8 can be written as 2 power 3. So capital N value is 3. So you will be having 3 select lines. In the case of 16 to 1, similarly 16 can be written as 2 power 4. So capital N value is equal to 4 and you will be having 4 select lines. So multiplexer is a device that allows digital information from several sources to route into a single line for transmission over that line to the common destination. The basic multiplexers will be having several data input lines and only one single output line. It also has data select inputs which permits the digital data on any one of the inputs to be switched to the output line. This is a typical example or application of a multiplexer. Consider you're having a surround system where you'll be having many inputs to the surround system. As shown here, you're having 4 inputs, which is MP3 player, laptop, digital select, satellite and digital cable TV. Since there are 4 inputs, you'll be having 2 select lines, which is represented here as B and A. So based on the values of the select lines, any one of the input will be routing its information to the surround system. So if BA value is 0, 0, the MP3 input source will be selected and it will be displayed at the output. If the select line is 0, 1, laptop source will be selected. If the select line is 1, 0, satellite source will be selected, and if the select line is 1, 1, then cable TV will be selected. So based on the select lines, any one of the input will route its information to the digital surround sound system. So this is a functional block diagram of a multiplexer. So here we'll be having 2 power n inputs, which is represented as I0 to In minus 1, and you'll be having only a single output. So based on the number of inputs, you'll be deciding the number of select lines. So select inputs will decide which input will be selected and it is routed to the destination. So this is a 2:1 multiplexer where you'll be having 2 inputs, 1 select line and 1 output. Say the input is I1 and I0. Since you're having only 2 inputs, you'll be having only 1 select line. So if the select line is 0, I0 input will be selected, and if the select line is 1, I1 input will be selected. The output equation will be I0 into S bar plus I1 into S. So this is a 4:1 multiplexer where you will be having 4 inputs D0, D1, D2 and D3. Since the input is 4, 2 power n is 2 square, which is equal to 4. So capital N value is 2. So you'll be having 2 select lines S1 and S0 here. So if S1, S0 is 0, 0, D0 input will be selected. 0, 1 means D1 will be selected. 1, 0 means D2 will be selected. And 1, 1 means D3 will be selected. So this is how a 4:1 multiplexer will work. So the output equation can be written as S1 bar S0 bar D0 plus S1 bar S0 D1 plus S1 S0 bar D2 plus S1 S0 D3. So here S1 and S0 determines the selection input values. So this is the logic diagram of 4:1 multiplexer. So if you see here, So the first AND gate will be having D0, S1 bar, S0 bar. Second AND gate inputs are D1, S1 bar and S0. So similarly, the AND gates are connected to the inputs and select lines, and all the AND gates are ORed together to form the output Y. This is the 8 to 1 multiplexer where you will be having 8 inputs, 3 select lines and 1 output. The logic level applied to the S input determines which AND gate is enabled so that its data input passes through the OR gate to the output. So you are having 3 select lines here which will be represented from 0, 0, 0 to 1, 1, 1. So for one particular combination, one particular input will be selected as shown in the truth table. So these are the uses of MUX. So MUX is used in data communication for several computers to communicate over one line. So in a network, many computers will be connected together to a common server. So if you want to see information from one particular computer alone, so based on the selection inputs, one particular computer will be selected and you can see the information. It's also used in radio networks where you're tuning your radio to a particular channel and you are receiving only one particular channel. It is also used to route data within a computer and used for function generation. Let us see how you can implement a logic function using a MUX. So this is an example where you are having 8 inputs which is represented from 0, 0, 0 to 1, 1, 1. The corresponding Y output is shown here. So you are having Y as 1 only for first, third, fifth and sixth inputs. Okay, so you can write the equation as for the first one the equation can be written as A2 bar, A1 bar, A0. For the third one it is A2 bar, A1, A0. For the fifth one it is A2, A1 bar, A0. And for sixth one it is A2, A1, A0 bar. So the Y input will be addition of all these 4 inputs. So the first, third, fifth and sixth inputs are connected to the high value and 0, 2, 4 and 7 are connected to the ground. You are having 3 selection lines A0, A1 and A2, and this is the how the MUX is implemented. Next we'll have some few assessment questions. So in a multiplexer, the selection of a particular input line is controlled by A. Data controller, B. Selected lines, C. Logic gates, D. Both data controller and select lines. Yes, the answer is selected lines. Next one is how many select lines would be required for an 8 line to a 1 line multiplexer? 2, 4, 8 and 3. Since the number of inputs is 8, you require 3 select lines. 2 power 3 is equal to 8. So capital N value is 3. So you need 3 select lines here. Thank you for watching this video.